5 here, which I know sometimes I skip points to just make it more obvious and stick out. This is one of those situations where you don't have a second chance. If you don't pay by tomorrow, if you show up on Friday with money, you will not be let in. If you bring a friend that you did not register, they will not be let in. This is one of those things where like the deadline actually legit matters, and we will say, no, I'm sorry, we told you by Tuesday. So if you would like to make a note in your plan book right now, if you need to go home and remind a parent to pay on My Payments Plus, you cannot just bring in cash. You cannot show up tomorrow with cash. It is on My Payments Plus. That is the only option. If a friend is coming, we need to know by tomorrow. We need their payment by tomorrow. And we need to be able to check that they're in good academic standing. I don't know who pushed this over here, but you guys can move it. Like, it's bothering you like it bothers me. It is just, like, kind of not centered in that corner, and it just feels weird. What's up? Oh, my God. I don't know. I'm not in charge of this. I just got told to keep announcing it. So I don't know if there's, like, a theme that anyone is supposed to, like, follow. If you guys want us to, if you guys decide to make a theme, I don't care. Well, Pettigrew's sick now. Like, she's legit. It's not just like Luke is sick like it normally is. Like, she legitimately is sick. So anything extra, you might, like, Mrs. Denies, you might talk with her because she does more with, like, themes and, like, Spirit Week and stuff. I don't even know if I can come this Friday. I've just been asked to make sure we keep announcing it because, like, if you show up Friday with $6 and you're like, sorry, I forgot, we're going to say, sorry, you can't come. Like, that's just how it has to work for this one. Because we, like, hired a DJ, we're buying food. Like, we have to plan ahead of time. Does that make sense? Like, we're not trying to be mean. It's just sometimes deadlines actually matter. All right. So, your 624, your homework for today is on the back counter. But I had requests from the previous homework that we've done. And from grading your homework, I have a couple things that I think we should probably review. So, please get out 611, 612. I forget if I have anything from 613 up here, but like, get out your done homeworks, right? Like the beginning of chapter 6. Just pull those out so we can talk about a few problems. Just pull out your chapter 6 homework if you would. Yeah, unless you handed it in this morning, I think I handed everybody's back. I don't know that we're going to have time to talk about the mastery today. I might save that for tomorrow because I wanted to prioritize like stuff you're actively working on. The mastery is more like it's done. Right, like, I mean, yeah, we might need to fix it, whatever, but, like, right now, you're actively doing your homework, so I wanted to address these homework questions higher priority than talking about the mastery. All right, so this one tripped up some of us, and I think I went over it in one of our classes, but I'm not sure if it was this class, and always some people are absent, and I'm not sure if I was recording when that happened, which let's check. All right, I am recording now. So, one of the most important pieces here is that either we need to look at the graph accurately or we need to read. I typed that in there because I know that sometimes it's a little tricky to like read these graphs. When we're talking about tile patterns, this is from 611 by the way. We're starting like as far back as I can. We're talking about X's and Y's, right? Where X is our figure number and Y is the amount of tiles. So X is our figure number, and the amount of tiles that we have is our Y value. So if I go to make a table out of this, that's going to help me the most. So I think this request was actually from the other class, but in case you are at all like nervous when these problems come up, and there's another one on one of our recent homeworks, different than this, but similar. So you can build a table with X's and Y's. Always know that your table should start at 0, even if you don't know what 0 would be right now. So I know figure 1 has 11. I know figure 3 has 7. So we can figure out this went down by 4 in the span of these two. So what are we changing as each figure? What should this be? Yeah, that should be -2, so we can make this 9, make that 7, then we keep going. But we really need to figure out what is our 0, right, which would have 13 tiles, meaning the rule, remember our rule is just like the equation. So our rule is that y equals, are we growing or like, are we growing positively or growing negatively? Negatively.
Subtracting 2 each time.
So -2 times x. What? Anybody? Plus 13. So I'm not trying to use cards right now because I know like these problems are a bit tougher. So I'm just trying to like let people shout out help. Anyone confused at how I got this? My 0th would have 13
Would
tiles.
Lane Bergen please report to the Perry office for just a moment? Lane Bergen to the Perry office for just a moment, please.
And guys, some of us haven't turned this homework in yet. Hopefully I get time to like call people up because I'm putting these in math today during my planning period. I ran out of true confession, my computer died over the weekend and I didn't have my charger with me. So my wife used to have the same computer charger. Her work gave her a new computer. I didn't know. I didn't plan. I made a mistake. It happens. Okay, don't pout about it. Just take control of it. So,
I'm double checking that I was grabbing off my thing.
So 6-3. Sorry, this is same homework, but I kind of went backwards because this problem got requested. I just want to talk about this. Look at 6-3 from 611. Like you should either have it back as a check, or if you don't have it back as a check, you might need to keep working on it. When you look at this line, immediately your brain should shout something at you about the slope. Is this line a positive slope or a negative slope? Yeah, and it scares me that we're not more like confident with that. As I go left to right, am I going up or am I going down? It's going down. This is a negative slope. And some of you forgot about that. Some of you did not indicate that it's negative. So the equation of this line, remember that we're always working in mx plus b. Which part there is our slope? So anybody, I just shout them out.
Why?
The m, right? Our slope
I was thinking about why.
is what keeps happening as we move, right? It's like what is impacting as we move. Meaning the b is our y-intercept. Guys, if you need to write down these reminders, write them down. That's why I'm going over this. Because we just got back into this chapter. I know we haven't done this in a little while. Y-intercept. Guys, the other way to remember this is that's when x is 0. Right? On the y-axis, this is when x equals 0. So if I plug in x equals 0, I'm just left with the b. X, right? Our x value, because I got some faces that I don't quite know how to read. Like I'm trying to read your faces and figure out like if this makes sense or if you're like, what the heck are you talking about? As x changes, is the line going up or down? We know it's going down. So we say, all right, when x is 0, right here, what do I have? I have a value of 1. For my slope, we need to figure out the, can anyone remind me how we talk about m, the little, what we put something over something, involve deltas? Vivian? Yeah, the other way to say that, and if you need to write this down, write down that reminder. It's y over x, but not the point. It's the change. That's why we use those triangles, the change in. So if I look, I'm going to make a big triangle just to make it obvious to like see the difference. If I look here to there, like that point to that point, what was my change in y? -5. What was my change in x? 3, and that's positive, right? Because it went forwards. Is it negative? No, that's -6. Counting is hard. No one's going to catch me on that? Yeah, 1, 2, 3, 4, 5, 6. So if I put negative 6 over 3, what's my slope? Negative 2. So we would say y equals negative 2x plus 1. Questions on how we got that equation?
Just to double check. The change in y over change in x is the same as like rise over run, right?
Yes, yep, rise over run. But here we're not rising, right? Or we're rising negatively. Yeah.
That hurts my brain.
So the x and y intercept, guys, we already know the y-intercept. We've already talked, like at this point, you know the y-intercept. You already wrote it down. I mean, if you did part A, what was the y-intercept? 1, right? So our y-intercept, we could say is 0, 1. Our x-intercept is where it hits the x-axis. Where does my line cross the x-axis? Yeah, it's a half. So it's a half 0, or you could say 0.50. Questions? To be parallel, what are we going to have to match? I tell you. To be parallel, what do we have to match? The slope. We need same slope. That's really skinny. So for a parallel line, all I have to do is match the slope. That's the only thing that has to match. Y equals negative 2x plus 87. Doesn't matter what we put here, but then they tell us I got to do what?
Graph it.
Well, but so same slope, but then if I keep reading,
You graphed above through the origin.
yeah, I can't just willy-nilly throw some random number here. I want to be through the origin. What's my y-intercept if I'm going through the origin?
0, 0.
Yeah, it's 0.
And same for the x-intercept. This is at the origin where it
So
was 0.
really my equation is just y equals negative 2x. That is parallel, same slope. But if we have to go through the origin, then you don't need the plus 0, but you can't have any other number. Now I just wanted to be parallel, I could plus or minus whatever I want,
And then we have to
as long as you keep the slope.
write it on, right?
Yep.
It said on the
Yeah.
same set of axes graph.
I care more about seeing you knowing that the slope is parallel. But I mean, yeah, you should also see that the lines will not cross. Biggest trapdoor I keep seeing people fall in is negative slope. Which is why the next problem I have up here is from 612. Problem 14. Now this doesn't have negative slope, but it does compare to positive slopes. Excuse me, so if you're not looking at 612, maybe get that out. Guys, first things first, you gotta draw axes. Nothing up here indicates axes, it's just a graph paper. You have to give me some axes somewhere, and I don't care where. You just gotta decide where to put axes. I'm gonna put them on the graph, so it's not at the edge. But I'm not gonna put them dead center. I'm just gonna throw them on the graph, just so I can see all 4 quadrants. Again, I'm not using cards, so I don't want to stress anyone out. Can anyone walk me through how to graph 2x plus 3? 2x plus 3, because I think we need a reminder on this stuff. Madeline?
So I start at 0, 3.
Yeah, always start at your y-intercept. Now, alternatively, you could make an xy table and start, okay, if x is negative 1 or 0 or 1 or 2, and you could start filling in x's and doing the math. Or Madeline says, hey, I know when x is 0, y is 3, so I'm going to start at 0, 3. Can anyone not Madeline pick up and tell me what to do now with the other, Kyrie?
And for the next point, you go over 1 and then go up 2 since it's 2x.
This, it's positive 2, I'll make it green. Says 2 is 2 over 1, right? If I make it a fraction. So what that's saying is as I move forward, I go up 2. As I move forward, up 2. As I move forward, up 2. Or I could do the math. This would come out to be 5. This would come out to be 7. This would come out to be only 1. And I'm going to cheat because I have that option. 2x plus 3. Similarly to what Madeline was talking us through with the first one, I'll make this one purple. So we could either set up an XY table, if you forget how to do slope and intercept, or we say, here's our intercept of 1, intercept of 1. What's the slope here? There's no number in front of x. What's the slope? Anyone? 1! Guys, they don't have to say 1 Will, 1 Nolan, 1 Harry. No, when I say Will or Nolan, you know I'm talking about one of you. So when we say x, you know we're just talking about one of them. So my slope being 1, up 1 over 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 1, up. It does the same thing over and over and over forever. Now this line, technically, for what it's worth, if I have the graph to show it, I should actually, this line should go all the way across the graph. Like if you want it to be right, that line doesn't stop, right? And if you want this one to be right, technically that line doesn't stop. So if I work it backwards, boop, 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 boop. And here's why, because I'm pretty sure this problem asks you, where do they cross? Where do they intersect? And we find that point right down there. Questions on that one? This I think was from 613. That or 621, I forget. But problem 47. I'm not gonna do this for you. I'm just gonna remind you. Our y-intercepts are the 2 and the 6. Right? Our slopes are -1 and +3. So your graph here should have one line increasing as it goes and one line decreasing as it goes. If both of your lines are increasing, it's wrong. If they're both decreasing, it's wrong. Negative slope should be going down as it moves left to right. If you need help on this, come see me. I don't want to go over like all of every problem. I didn't get any other requests. Has anyone now realized, like, oh man, I should have sent a request because I would like to see this problem gone over? Because those homeworks were due last week. We're maybe at 50% of people with homework turned in, but we're not doing great right now. And I'm going to blame science fair, which, I mean, isn't really an excuse because we got to learn to manage our time. But Lydia?
On 611, 6-7 with the hippos, I forget exactly how to write the equation that compares them, and then you solve it, and that's the answer kind of thing.
Hippos. Biggest suggestion here would be start by getting a highlighter and highlight what goes with what. So we kind of have like it coded of what we're actually doing. All right, so when he got to the pond, has the activity started yet?
No.
When he got to the pond. So what, like, relating that to us, like, graphing things, that will be like our,
Origin?
not, origin 0, 0. So be careful. We're not starting with 0.
30.
That's the number. You are correct. If we think about, like, this is going to look, we don't have, I forget if we're supposed to, but, like, we're going to think this through as if we were going to graph it, right? when we think about making a graph of this situation,
I'm pretty sure it'd be the y-intercept.
yeah, that's what we're starting at, right? Our y-intercept, even though our lines keep going, we talk about the y-intercept as like where we start at. So we're going to start at 30. So that is our y-intercept, 30. Would somebody back there shut the door? I think 8th grade just got back from the high schools. If he's eating 5 lily pads, is that positive or negative?
Slope and it's negative.
Yeah, that's negative. Because it's every hour. Now, I think it was somebody from 3B who emailed me, and maybe it was somebody from this class, so my apologies if it was you, about how this is inaccurate and hippos can eat lily pads way faster than this.
I did it with her.
Yes. So, brilliant, loved it, thought it was hilarious. We've been too busy to like take much class time with that. But yeah, so our equation here would be that we started with 30 lily pads minus 5 times every hour. Or if you want to write it the way that we're used to, it would be negative 5x plus 30. But since you started at 30 and are removing 5 every hour, this is a fine way to write the equation. We like it like this better, but this is fine. We had 30, we're eating 5 every hour. Henrietta found a better situation.
The hungrier.
Her pond started with 38, but she's eating how much? 7 for every hour. We do not need to graph this. That is totally unnecessary. What are we trying to figure out in this situation?
Like when they have the same amount of lily pads as remaining.
When they're gonna be equal. So we want to set up 30 minus 5x to figure out when will that be equal to 38 minus 7x. So while we could graph this, you really don't need to. We need to set up that equation and solve. I would start by adding 7x if you follow like not right versus wrong, right? But I always start by getting rid of the most negative. Negative 7x is the most negative. I'd get rid of that. I would add 7x to both sides. I'm not going to finish this out for you. Then once you figure out what x is, we can plug it back in, right? Once we figure out what x is, we can plug it back in. Questions or other homework questions? Other homework questions from stuff from last week. Last call. Let's, if you don't have 624, grab that. If you need to turn anything in, put stuff in the bin. Like, we have like 1 or 2 problems to do together. But like, again, I don't have a huge lesson today. But I don't think I have time to talk about the mastery right now. I don't want to rush talking about the mastery. I'd rather just like save that for tomorrow. You do not have to copy the graph because I put it on your paper for you. What I do need you to do is turn to your neighbor and start discussing the answers to the questions it asks you. So if you are still sneakily trying to do your homework, it's obvious you're not very sneaky. Switch over to 624. Switch over to 624. Start chatting with your partner. Do we think these are similar? If we do, how could we get from A to B? How could we get from A to B? Now we don't know the names of the points. We just know the names of the shapes. Right? We don't have specific names of points.
Can we make specific names of points?
You can, but you don't have to. Like, it will be more difficult if you name the points. It's easier if you just try to work with just the shapes. Because if you name the points, it'll matter if we flip. Right? If you don't name the points, if you flip, it doesn't matter.
I'm not going to name the points. You just have to finish writing in the date.
Or you change it to 90.
All right, I just want to rapid fire a few people if you think it's similar. Aaron, did you guys think it's similar? Caroline, do you think it's similar? Lila? Chase? Harrison? Okay, sounds like we've all agreed. Seems similar. Will, say more about why you think it's similar.
I think it's similar because on shape A you have 2x4, and then on shape B you have 4x8, which is shape A is half the size of shape B, and I think it's been either like rotated or just weird or something.
Yeah, like, who else agrees with Will? Like, we think there's a scale factor of 2, or depending, you could say scale factor of 1/2,
Yeah.
right? Depending on which way you go.
2
Because
and
2 and 4 compared to 4 and 8. See, so then Will says, well, something like there's something rotated at some point, right? So, Jeremiah, can you tell me how you would want me to start? I just want one step for how to get A onto B.
Maybe translate it.
Sure, but tell me how. Translate how.
Like across the.
Do you mean reflect? Okay, so you mean reflect. So Jeremiah just said reflect across the x-axis. Not the only option. I'm just going to follow what Jeremiah said because the card said pick Jeremiah. So if we reflect across the x-axis, and actually guys, regardless of what you did, let's follow Jeremiah. So it's okay if your paper ends up looking a little crazy. If we reflect across the x-axis first, A prime ends up there. Is that what you meant for me to do? Just checking. Because that's fine. Remember, this is the x-axis. So if you reflect across the x, that takes us there. Cool? All right, so there's my first thing. Lydia, what could I do from here? We'll call this A prime. What can I do now?
you can dilate it.
Say more.
Dilate my tail.
Say more.
Scale factor of 2.
From where? Remember when we were working with dilations last week? And that one shape kept getting farther away from the origin?
From point. Not
Guys, I gave away my papers from last week, but if you, I forget which one it is, and I was really hoping somebody would just have it sitting here. Ooh, maybe you do. Nope, that's a different one. One of our examples from class, this one. We were dilating, but remember this quadrilateral kept getting farther away because as we dilated, if you use the origin as your center of dilation, you go twice as far away from the origin. So, hey, this is where I need you actually paying attention. Lydia can dilate from the origin, but if she does, these points are going to end up off our graph. Because all of these points will go twice as far away from the origin. Or we have to say we're dilating from a different point. Or you could say dilate from the middle, like you could put a point right in the middle here and say we're going to dilate out from there.
It's still gonna go off the graph.
It would still go off the graph, that's
So
the problem.
from the bottom right point.
So from the bottom right,
Yeah.
that'll still dilate off the graph. Which like is okay, but if we use this as our
Top left.
center.
Oh, top left then.
Ooh, so you want to use top left as your center?
Yeah.
Hey, this is the biggest point of today's lesson, that your center of dilation matters. So, like I would do this with me, we're going to dilate with a scale factor of 2 from, Lydia said top left point, which is -6, 4, which means that point isn't gonna move. If that's our center, everything else is going to get twice as far away. So Lydia said use this as our center. So now, if this was 4 over to get to the top right, now it needs to be 8 over to get to the top right. If this was 4 and 2, double both of those. Now we need to go 8 and 4. We'll call that a double prime. Your center of dilation doesn't move. Everything else does. So another option could have been if I could have gotten A to come over here. If I could have gotten A to be there, and then I could dilate out, dilate out, dilate out. Like, you could have used this center and dilated everything out. Like, there's lots of options here. That's what I'm trying to get you to hear. There's not one right way to do this. I just need to make sure that you're aware center of dilation matters. You both have hands up in your partner, so I don't know. Rock, paper, scissors.
We're probably
who
gonna
gets
say
to
the
go?
same thing.
Can I say it was
Yeah, you can. It was your idea.
So I had a different approach where you would orientate it from the top right corner of the smaller one and the bottom left
A
corner.
prime, a double prime. What do you mean the smaller one?
A.
Okay, just checking I know what you're talking about. That's why we label things. Go ahead.
And I would put it at. Sorry, I'm figuring this out.
You got
Zero,
Well, hold on.
negative.
Well, so what you're trying to do is really difficult, and that's why we're going to practice the other way around. Let's practice following directions, which will help us be able to give directions. Move on to the next problem on your paper. It's okay, this one's not totally done. I'm trying to budget time. Your directions are not on your paper. They are up here. Because I didn't want you able to do this without me. We have to do these in order. Okay, so I'm going to color code them and give you a head start. But like starting with A, we're going to follow their steps in order. So the first thing we're going to do is reflect across the X, which I want to remind you because this is a trap door. This is your X axis. When you go across it, you move like you're coming down, right? You're shifting vertically. You're not really shifting vertically, you're reflecting. But this is why some people get goofed up with like which way. The X-axis reflects us like down. So go ahead and do that reflection. Reflect A across the X-axis. Then, if you've already got that done, go ahead and follow step 2. Since A was one above the axis, A prime should be one below.
Yes.
Why did you make it label it 1?
I don't know.
A prime, not 1.
We have not done many rotations, which is also why we're practicing this. Look up here.
Yes, sir.
I really wish I had brought, well, I don't even know if it still exists or if it got thrown away. My friend had a hockey stick in their attic they found at this house they bought. But imagine a hockey stick, right? Hopefully you know what a hockey stick looks like, right? You've got the stick and then the part on the end. So just imagine that a hockey stick is just a right angle. This is what we're going to call the hockey stick method. This point out here, we're going to draw a hockey stick to get to it, but follow the axis first. So from the origin, we're going to draw a hockey stick. 1, 2, 3, 4, 5, and 1. So go ahead and like highlighter something on your paper. And imagine that you're on the ice. Right? Imagine that you're on the ice, where hockey gets played. By the way, the Jackets are doing really well right now. If you haven't been paying attention, our local hockey team is doing really well. So let's go Jackets. But imagine you stand on the end of the hockey stick and you kick it so that it spins. The first kick we do is just going to be 90 degrees around, and they show us right here, we need to come 90 degrees this way. So my hockey stick was right here. I kick it 90 degrees, and it spins 1, 2, 3, 4, 5, and 1. So I had my original hockey stick. I spun it.
Hockey stick prime.
Now it's here,
Hockey stick prime.
and it tells me my new point is here. Let's draw another hockey stick. I'm going to change to like pink. So this other weirder point, 1, 2, 1, 2, 3, 4. Right? If I draw my hockey stick, guys, there are other ways you can do this. If you look up rotating on a graph or whatever, it'll tell you take X, Y, and do this. There's all sorts of tricks.
Hockey
This,
stick.
I think, visually is what makes the most sense. Visually. So when I kick the hockey stick 90 degrees instead of 2, 3, well, it's still 2, 3, but turn it 2, 3, and I end up here. What's my final hockey stick, my little one? To get to that closest point, my hockey stick is 1, 1. From the origin out to your point. So now kick your hockey stick 1, 1. And we should end up right there. Yes.
I can barely see the light pink ones.
Yeah, especially from that angle.
Like,
I mean, there's not a lot that I can do about it quickly. If I had more than a minute left, I'd probably go try to change the colors, but I mean, I can redraw it in a different color, but like,
Yeah.
it just, a lot of them are hard to see. Like 2, 3, right? So I always follow the axis first. So 2, 3 stays 2, 3, it just spins, right? Turns at 90 degrees. And then we could dilate by a half, but since they don't tell us a center for our dilation, it's assumed to be the origin. We're going to pick this up right here tomorrow. We're going to pick up these steps tomorrow. Because like you can still do pretty much all the homework, I think. Because anytime we do class stuff, it's not necessarily on that night's homework. So like rotations, I forget if rotations are on tonight's homework or not. If there is, you can skip it for now. We'll talk more about it tomorrow. Caroline?
I don't know if I got this wrong, but I think on A prime, I think it was -2, -4. Like for the top or the bottom.
Are you talking about like the hockey stick we drew, or what are you talking about? You guys can head to lunch. Have a great day. Ooh, working at 10.
or not, whatever.
So,
Buy
you'll
back
start
when
with
they
the
told
origin
half.
and draw the hockey stick. So whichever axis you follow first. Like so, if you follow this axis first, highlight it all now. So we're doing 2, 4, and sure you can call it negative. I just am drawing how long the hockey stick is. So if I have 2, 4, and I kick it 90, and my 2 is right there, and my 4 is right there. See how like the whole hockey stick rotates? Does that help? Bad word.
Oh no!
Huh?
They're relatively simple.
Someone say the E word.
Mm-hmm.